In this play posit, we're going to be looking at the different mixtures and different types of mixtures that you're going to run into in chemistry. So you may look at my coffee cup and notice how I'm not drinking, grounds through a straw. I'm drinking the actual coffee. And we're going to figure out how mixtures and the different aspects and different properties of chemicals allow us to make separations occur. So a mixture is a physical blend of two or more components, and most samples that you're going to look at are going to be a mixture. And a great example is a salad bar. So whenever you go to a salad bar, there are all these different types of mixtures that you can make. You can go there and get lettuce, spinach, or some type of blend, and right away you're going to start making a mixture of salad as well as, broccoli and all different kinds of things depending on your preference. So with a salad, you can see all different kinds of different components of that mixture. However, with gases, it's a little bit more difficult because the fact that air can be drier or more humid shows like one component, which is how much water vapor is in the air. But you can't look up at the sky and say, you know what, it looks rather nitrogen-y out. You just don't make that connection. So it's more difficult, but still possible to make, to dissect the gases in the air, but you can't actually physically see it. So a mixture which is composing things that are not uniform, meaning you can see the different components, are a heterogeneous mixture. That means that you can see all different components by just looking at it. Now, if you look at this salad, I can definitely pick out, tomatoes and corn, avocado, lettuce, green beans are in there. Maybe that's bacon. I hope it's bacon. But you can see all those different components in that salad. Now, that is a heterogeneous mixture because I can point to each individual portion and show you and tell you what is composed of each little piece. However, there are things called homogeneous mixtures as well, also known as homogeneous, depending on how you like to say it. Now, a homogeneous mixture is uniform throughout. So if you look to the right here, you have oil on the left and vinegar on the right. You can see that homogeneous mixture is a clear see-through mixture, but in all reality, there's actually a few other things that are mixed together, blended together to make oil as well as vinegar. Another name for a homogeneous mixture is a solution, and you'll be using plenty of those throughout the year. Whenever you are looking at homogeneous mixtures, you may run into the term called phase, and that doesn't mean that it's a solid, liquid, or a gas. However, it is going to have a different layer to it, to that mixture. So for a homogeneous mixture, it has one phase. However, if you were to mix those two together, you're going to start to see a heterogeneous mixture that has two phases. So you can see the top phase here, that one is heterogeneous and it has two phases. This is the oil phase and the bottom is the vinegar phase. So you can see that the one is floating on top of the other, and therefore you have multiple phases. This would also work with water. Oil will float on top of water, giving you two different mixtures, or two different phases. So let's say that you're at the beach and you realize that the ocean water and sand are mixtures. Which one is homogeneous and which one is heterogeneous? Well, if you look at the ocean, you do not see all the different particles of salt inside of the water or the different compounds inside of it. However, the sand is a heterogeneous mixture. And if you've ever used one of those strainers that the little kids you see the little kids playing with at the beach, you could definitely strain larger pieces of sand away from smaller pieces. But if you were to do that with salt water, it would just have the water go all the way through. To separate mixtures of things like olive oil and vinegar, you can decant, also known as just pouring off the top layer. So if you think back to the oil and vinegar, you could easily pour off the top layer until it's just vinegar at the bottom. However, you might be able to use other properties to make it easy to separate. So oil actually will solidify or become a solid before vinegar. So you could easily cool that oil layer until it turns to a solid and take advantage of that temperature difference and have the vinegar easily poured off of that solid oil. Both work, but both are very different approaches to separating mixtures. Now back to my coffee. There is a big example of filtration. Every time you go to Starbucks, they are using filtration to separate grounds from the coffee. Now, coffee is liquid and the grounds are a solid. So they're able to separate these two things by a little piece of thin paper that allows the water to go through. However, it does not stop the liquid from going through. It stops the grounds, lets that liquid fall to the bottom, and helps me survive the school day. So that's called filtration. In a lab, filtration is pretty much the same thing. Filter paper is going to be placed in some type of funnel. The mixture is going to be poured into that funnel, and then the solid things are going to be stuck in the filter, and the rest are going to pass through. So there's also something called distillation. Distillation is a way to separate different mixtures of liquids that are dissolved in water. So one way to separate water from other components, let's say in tap water, is through something called distillation. And it looks a little bit something like this, where you have a mixture of things from your tap water. So in your tap water, you have fluoride and a couple of other minerals in there that come out of your tap. But if you were to heat it up, that steam is going to be pure water. It cannot take that fluorine or any of those other minerals with it. It'll then go through this small mouthpiece, and it's going to go into something called the condenser, and you can see that name right here. The condenser is going to do exactly what its name says. Take that gas and turn it into the liquid form again. Once that occurs, the liquid will come out of the spout into the receiver flask, and this water that comes out is distilled water. So if you've ever had distilled water from the store, this is how they make it. Now what's left in the flask back here is all of the heavier things. So things like fluoride and chlorine and things that are put into the water to make it clean will stay back in this beaker because they have different boiling points. So you will have completely distilled water at the end, despite starting with that tap water, all based on their different boiling points. So here is a run through of what I just said if you need to read through it one more time, and a continuation of that information. So you are given a mixture of aluminum nails and iron nails. So like aluminum from your drawer versus iron that you may not have iron nails. Those would be like from Home Depot. So how would you separate them? First of all, we have to identify how to separate those types of nails. They're both solid, so that doesn't work. What else? Let's see, they're both metal, so we can't really get rid of that. They're both gray, so we can't separate by color. Both of them do not dissolve in water, because if you put a nail in water, they still are a nail. Thankfully, otherwise our houses would all fall apart. However, there is one key difference. One big difference is that aluminum is not attracted to a magnet, whereas iron is. So if you were to go grab a magnet off of the refrigerator and hold it over your pile of nails, the iron nails would be attracted to it, whereas the aluminum nails would stay flat on the surface. So that ability to be attracted by a magnet is a property that iron has and aluminum does not. So you could easily separate that mixture through the magnet, removing the iron nails from the mixture of aluminum. So this takes the properties of the mixture and is allowing us to filter out the nails that you want versus the other nails that you may need in a different spot. As usual, there are the vocab words at the end of the PowerPoint if you need them and feel like you want to write them in your notebook. It's up to you. But they are also online if you desire.